OK, welcome back, everyone, to Web Programming with Python and JavaScript. So last week, at the end of last week's lecture, we talked a little bit about how we might design a web application that's designed to store data. So we looked at an example of a note-taking application where our goal was to be able to have users type in notes and save those notes so they could have a list of all of the notes that they've saved. And we found a solution that worked just by storing the notes inside of a list of strings in Python in our Flask application. But it wasn't great because if we were to ever shut down the web server and restart it again, we would suddenly lose access to all of that data. All that data would be lost. So what we're going to begin to talk about today is databases, and in particular, trying to find some way to use databases to make it easier for our web applications to store and manipulate and use data ultimately. And the types of databases that we're going to be talking about today are relational databases, which you can think of as effectively storing data inside of a table. So the example I'll keep coming back to today is thinking about trying to design a database that's going to potentially be used by an airline, for example, to store flight information. And so you might imagine that if an airline wanted to store data about flights, in the simplest of senses, they might have a table that looks something like this, where we have, for each one of these rows, each row represents an individual flight. And each flight has an origin, New York, Shanghai, Istanbul, somewhere else, a destination, and a duration in some units, maybe minutes. So we might imagine that you could design a spreadsheet, for instance, that would have 3 columns, origin, destination, and duration, and that you have one row for each individual flight, and each one of those individual flights would have an origin, destination, and duration, respectively. So that's what we're going to be trying to do, designing these sorts of tables, but we're going to do so using technology called SQL, or SQL, Structured Query Language, which is a language designed to allow us to very easily interact with databases, interact with tables of data that have rows and columns, for instance. And in particular, in this class, we're going to be using a particular version of SQL called PostgreSQL, although there are a bunch of different versions of SQL that have slightly different features and slightly different aspects to their languages and the way that they work, but they're all very, very similar. So once you know how to interact with one, it's very easy to see the parallels in others because the syntax ultimately is very, very similar from one language to the next. So we'll go ahead and dive right in and start just by thinking of the first thing that we would want to do once we have a SQL database, which is going to be creating a table. So when we're creating a table, we're going to need to decide what sort of data that table is going to hold. So we saw before in the table that I showed before that we had an origin column, a destination column, and a duration column for keeping track of different information about a particular flight. So all of that information needs to have a particular type. And so what we see here are a couple examples of the types of data that a SQL database might have. So data might be in the form of an integer or a decimal, which can have a decimal point. Serial is a common data type that you'll see in SQL or in PostgreSQL specifically. A serial data type is basically just like an integer, except it counts automatically. So anytime you add a new thing or a new record into your database, it will automatically increase its value. So this will be common if I want to give each flight a flight number, for instance, where I want the first flight that I put into my database to have flight number 1, the second flight to be flight number 2, third flight number 3, and so on. Serial is a useful data type that will just automatically increase its value one at a time. Varchar is another popular data type in SQL. Varchar stands for variable length of characters. So if I wanted to store a string, just some sort of text in a SQL database, varchar is generally the data type I would use for that. And there are a bunch of other data types as well. Data types for storing timestamps for a date and a time, a Boolean value for true or false, or an enum, which is just a way of saying one of a finite number of discrete possible values that I might have. We'll focus mostly on these top 4 here, though, for the purposes of today. So now that we have these data types, we need to use them in order to actually create a database table that we're ultimately going to use. So the first thing we'll look at is the syntax for how we would go about creating a table in Postgres, or in SQL more generally. So the syntax for doing that, we'll find in create.sql. And this is an example of SQL syntax, of text that we're going to be feeding into a database. And that database is going to interpret this SQL commands and use it in order to create a table. So what's going on here? On line 1, I said create table flights. And so that's telling the database to create a new table, just a set of rows and columns. And we're going to name it flights. And then when I create the table, I need to tell the database in advance what types of information my flights table is going to contain. And so you'll see that information, one on each row. The first thing that each table is going to contain is an ID. This is a very common paradigm when designing databases. We want it to be easy to reference individual flights, to be able to say, get flight number 28 and give me some details about that particular flight. And it's much easier to say, get flight number 28 than it is to say, get me that flight that goes from Moscow to New York, for instance. And so having an ID on every single table that makes it easy to say, this is the way that I want to reference flights is often very practical. And so this ID is going to be of type serial. Recall that serial is just an integer that will automatically count. The first flight will be flight 1, the second flight will be flight 2, etc. And then primary key just means this is the primary way via which I'm going to reference a flight, that every flight is going to have a unique ID. And therefore, if I tell you ID number 28, that will map to one and only one flight. Then on line 3, I'm starting to define the other columns that I care about. What else goes into a flight? Well, it needs an origin, which for now I'm just going to represent as a varchar, just text, just the name of the place from which the flight is departing. And I can additionally specify other properties of this column. In particular, I'm saying not null. So SQL databases support the idea that a column may or may not have a value. And so in some cases, you might want it to be the case that a column doesn't necessarily need to have a value, but can have a value if you want it to. But in this particular case, if there is a flight, it needs to have an origin. And I don't want there to be a flight in my flights table unless it does have an origin or city from which it's flying out from. And so I specified not null to mean that the origin column cannot be empty. And if you try to add a flight where the origin column is empty, the database should reject that. So you can begin to enforce constraints on what the database will or will not allow by adding these additional constraints after the name of the column and the type of the column. Likewise, on line 4, I'm defining a destination, which is also just going to be a varchar for now, just text. And I'm saying that this is not null. And then finally, I'm specifying a duration. This will just be in minutes, which is going to be an integer and also not null. Every flight needs to have a duration for how long that flight is going to last. And so this is the syntax for how I would go about creating a table. So once I have a SQL database up and running, and generally speaking, in order to do this, in Postgres at least, you need to start up a Postgres server. So you can start a server up locally on your own computer, which is what I'll be doing in today's lecture. But you can also find Postgres databases that are hosted online. In particular, for the next project that you all will work on, what you'll do is you'll be interacting with a Postgres database. And that database will be living on Heroku, which is an online platform for hosting websites and databases. And you'll be able to connect to that database remotely using your computer to connect to some database that's online. But for now, I'll just connect to the database that's local to my own computer. So I'll go ahead and go into psql. It's just a command that that lets me type in PostgreSQL commands. And I'm saying lecture 3 because that's the name of this particular database. In reality, if you wanted to use the psql command with a database that exists somewhere on the internet, that database would have a URL. And information about where to get that URL will be in the project instructions. But you could paste that URL in after the word psql in order to access that database as well. So now I want to create the table inside of this database. So I'll go ahead and copy this text, this create table flights with all of those individual columns listed one after the other. And I'll paste it in here. And now that table is created. So after that semicolon, that means the end of the command, Postgres said back to me create table, meaning that it successfully acknowledged the fact that I wanted to create the table, and it created the table for me. And I can verify that if I type \d, which just shows me all of the different parts of my database that exist right now. And I can see that I have this table called flights that exists right now inside of my database that I have now just created. So that was how we might go about creating a table in Postgres. And we talked about the various possible constraints that we can place when we want to create a table and we want to define what the individual columns do. So I can specify that a column is not null, meaning that it needs to have a value. I can specify that a column must be unique. If I don't want two people to share the same value in a particular column, I can enforce that in the database by saying this is going to be a unique column. So for instance, if you are managing a database of users and every user has a username, you might want that username field to be a unique column because you don't want two different users to have the same username, for example. Primary key is just the single way by which you're primarily going to reference a table. Usually that's going to be the ID, just the integer that's going to keep counting every time, that keeps track of which individual row you're referring to. You can give columns a default value. So if most of the time your column is going to have a value of 0, you might say this column default 0 to mean if I don't tell you what to put in the column, just put in a 0 by default and only put something else in if I tell you to do that. So that can often save time. And you can also add additional constraints. Check is another constraint that you can use to say, I only want to allow values that are less than 50 or less than 100, for example. And you can begin to add more constraints on those databases as well. Questions about how to go about creating tables, or what we were thinking about in terms of deciding what types each column should have and how that process works? OK, so we've created a table, and we've created this flights table. But right now, that table is empty. It's got no rows in it, so it's not actually storing any data just yet. So let's go ahead and fix that. The next thing we're going to talk about is how to go about inserting data into a data table. So this is what the syntax for that might look like. So if I wanted to take a flight and insert a flight into my flights table, this would be the syntax. First, I say insert into, which is the SQL syntax to say I want to add data to one of my tables. After that, I specify the name of the table that I want to add to. So in this case, I'm going to add to the flights table. In the previous example, we created a table called flights. Now I'm saying I want to insert into this flights table some data. What comes next, and this could all be on one line, but for the sake of space, it's broken out across a couple lines. I've specified in parentheses and separated by commas the names of the columns that I want to add information for. So I'm going to add an origin, a destination, and a duration for this new row that I'm adding. And you don't necessarily always need to add something for every single possible row. Note that in this case, I didn't add an ID, for example, which is the fourth column in the flights table, because ID is going to automatically increment on its own. We defined it as a serial type just a moment ago. And if you had a column that allowed null values, was allowed to be empty, you wouldn't need to specify it inside the insert if you didn't want to. Or if it had a default value and you didn't specify it here, it would just go to the default value since you didn't tell it what value to take on. But in this case, I want to add a new flight to my flights table. I want to give it an origin, a destination, and a duration. And now I need to tell the database, all right, here are the columns that I'm going to add for this particular row. What should their values be? And so we say values, and then in parentheses again, in the same order that I define my columns, I first am going to specify my origin, New York, then the destination, London, and then the duration, 415 minutes in this case. And so this would be the syntax for how to go about inserting a record into that database. Let's take a look at what that would actually look like if I were to go over here and go back into this database. I would say something to the effect of insert into flights. And then I would specify origin, destination, and duration. And then these values, I want to specify New York and London and 415 minutes. So semicolon, I press return. SQL says that I've now inserted that row into the database. And so now I've added a row to that table. We haven't yet looked at how to see all that data in the table just yet, but I have inserted that row into the table. And just for the sake of adding some sample data into that table, I have here insert.sql, which just contains a whole bunch of other insert queries. So these are all identical queries. Each one just says insert into flights. Here are the individual values I want to insert. And so I'm going to go ahead and copy these and paste them in here so that now I've got a couple of different flights that are inside of this database. So that was inserting values into the database. But next up is figuring out, once I have values in the database, how do I look at them? How do I see what's going on? And the way to do that is via what's called a select query. And so we've looked at create table, which creates a new table, insert into, which inserts a row into the database, so writing to the database. And select is a query that is meant for reading from a database. I already have rows in the database, and now I care about accessing those rows, figuring out what they are under certain conditions. And that's when I would go about using a select query. So what does a select query look like? Well, the simplest select query that I can run is select star from flights. Select star, star just means select everything, meaning all columns. And then from just means what table do I want to select from, because I might have multiple tables. I ran create table once to create a flights table, but I could just as well have created multiple other tables that are stored as part of the same database. So I'm saying select star from flights, meaning select everything from my flights table. And when I press return and run that query, what I get back is all of the data that is in my table. And it looks very similar to the table that we showed at the very beginning, but this is SQL telling me that, OK, here are my 6 flights that I currently have. Each one has an ID. Each one has an origin, a destination, and a duration. I only ever added the origin and the destination and the duration. But in particular, SQL has automatically added the ID for me, since I specified the ID as a serial column. And so this gives me access to all of that data just by running that select query. Questions about inserts or selects in terms of what we've seen so far? All right. So let's look at some of the other types of select queries that we can run. So select star from flights is the first query that we saw. So if our data looks something like this, with 6 different flights, each one with an ID, origin, destination, and duration, select star from flights is going to give me back all of that data, where this light blue just means all of this data is information that you'll get back. And you saw when I ran that query a moment ago, this is exactly what happened. All of this data was displayed back to me and handed back to me from the database. But oftentimes when I want to query for data inside of my web application, it's not the case that I need all of the data all at once. In fact, that'd be probably quite a lot of data, especially if your web application starts getting big and starts getting a lot of data in it. So what I'd likely want to do is only select the things that I care about. So select star from flights means select everything across all of the columns of the table, get me that information. I could also do a query that looks something like this. Select origin, comma, destination from flights, where I've replaced the star, meaning select everything, with just 2 columns, origin and destination. And so if I were to run that query instead, then the only data that's handed back to me are the contents of the origin and the destination columns. So I don't care about what the ID of the flight is. I don't care how long the flight is. I just care where am I flying from, where am I flying to, and I'll get back that data for all of the flights that are inside of my table. And so it's easy in SQL to manipulate the data in the table to get back only the information that you want just by specifying in the query what information it is that you actually care about. If you only care about 2 columns, no need to select everything. You only need to select the columns that you actually want to get back. There are other ways to modify our queries as well. So select star from flights. Star, again, means select all of the columns. But I can add this where clause. And the where clause is going to allow me to, instead of restricting what columns I'm selecting, restrict what rows I'm selecting. So normally, select star from flights would give me back all of the rows inside of my database. But chances are, if my database starts getting big and I have a lot of different rows inside of my table, I don't want to necessarily select every single row every time I make a query. I only care about selecting particular rows that I care about in this particular instance. And so if I say select star from flights where ID equals 3, as you might reasonably guess, what that's going to do is instead of giving me back all 6 of the rows inside of my table, it's only going to take row number 3, and this is going to be the only row that's handed back to me from the database. Questions about that where clause so far? That where clause doesn't have to be just a number. It could be of any type as well. So I could say select star from flights where origin equals New York. And that's going to go through the database, find me any flight that's flying out of New York, and only hand me back that information. So I ignore all the other flights that aren't coming from New York, and I'm only getting these 2. And you can imagine that being practical if you're actually running an airline's web application and someone is looking for flights out of New York. Rather than query for every single flight and show all of that, you would only want to query for the flights that are flying out of New York, for instance, and only give back that data back to the user. So you can also, in addition to specifying equality, use the where clause to specify an inequality. So in this case, select star from flights where duration is greater than 500. What that's ultimately going to do for me is to say I want to select from flights, but only where this duration column is greater than 500, giving me back only the longer of the flights that happen to be part of this database so far. And so those inequalities are supported as well. And I can also use Boolean logic, ands and ors, to manipulate my queries as well. So in this case, I've said select star from flights where destination equals Paris and duration is greater than 500. And as you might reasonably imagine, the only row that's going to return here is row number 2, because the destination is Paris and the duration is greater than 500. And even though there are other flights that are duration over 500 or have a destination of Paris, those aren't selected because I only want to select ones that meet both criteria. And just as we can use an and inside of a Boolean expression in SQL, we can just as easily use an or inside of that expression. So I can say select star from flights where destination equals Paris or duration is greater than 500. And now all 4 of these are going to be handed back to me. This one because it satisfies both of the criteria. Row number 3 because the duration is greater than 500, and then rows 4 and 5 because I have it such that they both have a destination of Paris. And so there's a variety of different types of SQL queries that I can run in order to do a variety of different things. Questions on those so far? OK, let's take a look at a couple other types of queries that we can run, and a couple others of these examples of select queries. So I'll go back into the database, and we'll do a couple examples from ones we've seen before. So select star from flights gave me back everything. If I only care about maybe the destination and the duration, I could say select destination, comma, duration from flights. And that gives me back only those 2 columns, for instance. And then I can begin to restrict things. Select star from flights where destination equals Paris. And that gives me only the rows whose destination is Paris and ignores everything else. But where SQL starts to get even more powerful is when I can start using functions to begin to specify even more, with even more precision, what it is that I actually care about. So SQL, for example, has an average function called avg. And so maybe I care about knowing, what is the average length of a flight in my database. So I could say select the average duration from flights, where avg is my average function. I'm taking the average of the duration. And what I get is 501.6667, which happens to be the average duration of a flight in my flights table right now. And this is still just a select query. It just happens to have a function that's modifying one of the columns. I'm modifying the duration column. But I could add a where clause to this, for example. I could say select the average duration from the flights where the origin is New York. So that will only give me the average length of a flight from New York, for instance. And so you can begin to take these pieces and begin to put them together in order to construct more interesting queries. Another particular popular function is the count function, which just counts how many rows that are returned from the database. So I could say, for instance, select count star from flights to mean select all the rows from flights. That's what select star from flights would do. But instead of giving me back all the rows, just give me the count of the number of rows. Tell me how many rows are in my table, and that will give me back 6. But I could equivalently, or relatedly, try to say select count star from flights where origin equals New York, and that will give me back 2, because there are only 2 flights that are flying out from New York. And likewise, if I were to type in flights from origin as Moscow, there's only 1 of those flights. And so count can be used in order to figure out how many entries inside of my table have this particular property. And so that can often be very, very useful as well. Questions about any of those things that we've seen so far? Other popular functions are like min and max, which can be used if I want to select the minimum duration from my list of flights. And OK, the shortest flight is 245 minutes. If I'm curious as to which flight is that one that has a duration of 245 minutes, I could say select star from flights where duration equals 245. And that'll tell me, OK, that flight is the flight from Moscow to Paris. It's the flight with ID number 5. And so that's database insertion. A couple other things you can do. You can also specify using the in keyword a range of possible values. So in this case, I'm saying select star from flights where origin is in New York and Lima. And the result of that is that we get flights that are from either New York or Lima that get selected as a result. And likewise, I can start to do string matching, something like this, which is a situation in which I select star from flights where origin like %a%. So common nowadays are things like autocomplete, or where you can type in something partial into a search query, and you'll get back the full thing. This is doing something very similar. Select star from flights where origin like %a%. These percents stand in as placeholders, effectively, where they can represent any text. And so select star from flights where origin like %a% says select any rows from flights where the origin has an A in it, right? It has some amount of text, possibly none, followed by an A, followed by some amount of text. And the result of that is that all of the things that have an A in it are going to be returned back to the user. And you can imagine this being helpful if you have a database of information that you want a user to search through. And they might search for, ultimately, a substring of the actual text that's contained inside of the column. But you can use that information using a like query as opposed to origin equals something to say, find me all the things that match that thing that the user typed in, even if it's only a substring of the total thing. And so that can be useful as well. And so we looked at some of these functions, sum and count and min and max and average, that can be used as well. All of these are just different ways of selecting data, of specifying which columns we want to select, of specifying which rows we want to select, of restricting what rows come back. And ultimately, that is insertion of data. Question? Yeah?
Yeah, so the last query that you executed, I guess my question is, can you execute, not a query, I mean a function, can you execute a function in the where clause? So the last query that you executed, you did it in 2 different queries. You got the min, and then you looked at the value and put it in a second query. Could you have done that in 1 query?
Good question. So the question is about whether we could consolidate some of these multiple queries into a single query. We can, and we'll take a look at ways to do that in just a moment. So that was selection of data and how we would go about reading data from a database. But what happens if we need to change data that's already there, right? So that might be the other common use case, that I have data, I know how to insert data into the database, I know how to read data from a database. What if that data needs to be updated or changed? So that is where the update query is going to come in, where that is going to allow us to take data inside of our database and modify it in some way. And here's what that query might look like. So the query will start with the word update, which is just the SQL keyword to say I want to update some data inside the database. Following that is the name of the table that I want to update, in this case, the flights table. Then I say set duration equals 430. I'm setting the duration of some row to 430, or possibly multiple rows. And where is telling me which rows I want to update. So in this case, I'm saying update the flights table, set the duration to be 430 minutes, but only do that for columns where the origin is New York and where the destination is London. So any other columns that don't meet that where query are not going to be set to 430. If I omitted these 2 rows altogether and just said update flights, set duration equals 430, what that would have the effect of doing is changing every single row in my table to have a duration of 430, which is likely not what you want in this particular case. So the where clause is very important for specifying these are the only rows that I actually care about modifying, that I actually care about editing as I go about updating that table. Questions about the update query? Yeah? Is there a control Z? SQL does not have a control Z. However, one common paradigm you'll see as databases start to get bigger is the idea that you always want to keep database backups around. That you always want to take a database and have some second copy of it, such that if something goes wrong on the main database you're using, you can always restore it. And if you begin to use databases in production environments, so Amazon Web Services, for example, offers as one of its services a relational database just like this. And it offers built-in ways to help you keep backups of your database such that if you mess something up like this, you can have some way of going back to what you had before. Good question. So we've been able to add data into our tables. We've been able to query for data from our tables. We've been able to update data in our tables. The last thing that we might reasonably want to do is delete data from our tables. Take a row and just get rid of it entirely. And the keyword in SQL for that is quite logically just called delete. And that might look something like this. Delete from countries where destination equals Tokyo. That is going to sorry, this should be flights. Sorry, delete from flights where destination equals Tokyo. That will go through the table, deleting all of the flights that have that particular destination. So questions on creating data or updating data or deleting data from our database?
So let's say I delete one row and then add a new row. Then what is going to be, what will happen to ID?
Good question. So the question is, I delete one row, and then I add another row. What's going to happen to the ID? So maybe I have IDs 1 through 6. I delete the thing with ID number 3, and then I add a new thing. Is it going to be number 3 or number 7? The answer is that generally it'll be number 7, that the numbers just keep adding up, and they don't fill in the blanks from before. As we'll see in a moment, there's good reason for that. And the reason has to do with the fact that because we will oftentimes want to represent relationships between tables, which we'll soon see, it can often be very, very helpful to be able to know that if I had the thing with ID 3, nothing else will ever have that ID again. Everything else will always have a later ID, even if I go back and delete that data. So yes, it will just keep counting even if I delete older things that existed in the database before. So other clauses that could be useful, and here we'll get into answering your question about how you might be able to group multiple things together. So let's say I wanted to select all of my flights, select star from flights. And right now I'm getting back 6 results. But you might reasonably imagine that I don't want to get back all of the results, especially if the table is large. I only want to get back a couple. And so there is a keyword called limit, which means I only want to get back a certain number of results. So select star from flights limit 2 is going to mean get all the flights, but only give me back a maximum of 2 rows. And so I only get back 2 rows from there. But of course, this is probably more useful if this data is ordered in some way, right? I don't really care about getting the flight with ID 1 or ID 2, but I might care about, for instance, getting the 2 shortest flights in my table, for example. And so I would want some way of sorting this table by a particular column. And the way to do that is via the order by keyword, which is one that will prove quite useful if you're ever trying to get a sorted list of your data and only extract out parts of that. I can say select star from flights, order by duration, and I'll say ASC for ascending, although strictly speaking that's optional in this case. And what I get now is rather than all of the flights in the order that I inserted them like they were in before, now I get them in order of duration, with the shortest flight at the top, Moscow to Paris, 245 minutes, and the longest one, Shanghai to Paris, 760 minutes, all the way at the bottom. And so if I only wanted to get the 3 shortest flights in my table, I might say select star from flights, order by duration ascending, limit 3, and that only gets me the 3 shortest flights in my database. And just as there's a keyword ASC for ascending order, there's also DESC for descending order that gets me all the flights starting with the longest one and going down until the shortest. Questions about any of that? Yeah?
Can we use the rollback commit to reverse the transaction?
Good question. Can you use rollback and commit? Yes. We'll talk about how you would go about committing changes a little later. But yes, you can roll back changes if you make changes and realize they aren't the changes that you wanted to make. That's similar to the Control-Z type of feature, but you have to tell the database that you are starting a quote transaction and then start adding to that transaction. But we'll talk more about that in just a moment.
Is there any tool I can use for this post-SQL, like a dot?
Good question. Is there a tool for like interacting with the database? Yeah, great question. So there are a couple different ways that you can go about interacting with the database. One is via the command line like we're doing now, where I'm just typing in SQL commands directly into pSQL, which is a program that lets me run commands in the database. One that we are going to provide for you in this course, which will prove quite useful to you as you work on your project, is called adminer.cs50.net. So Adminer is a third-party database service that lets you interact with a database online. And so what you'll do once you get a database for the next project is you'll likely want to go to adminer.cs50.net. You'll paste in the credentials for accessing your database, which you'll get once you start working on the project. And from there are tabs from which you can run SQL commands, from which you can look at all the data in a nice graphical interface. And so that'll just make it a little more convenient to look at that data as well. So you can either do it through Adminer or an interface like Adminer. There are a whole bunch of services like this out there. Or you can do it via the command line. Or as we'll see later today, we'll find ways of using our Python code to be able to interact with our database such that we can have a Flask application that itself is running SQL commands and interacting with the database as well. But we'll see all that in just a moment. Good question. So a couple of other things I want to say about how you can go about selecting data. We were talking about how to go about performing what might ordinarily take multiple queries, but combining them into a single query. Let's say that I wanted to find out what are the most popular places from which people are flying. So I say select star from flights. I see New York, Shanghai, Istanbul. What are the most common origins of flights? Well, I can run a query like this. Select origin and count star. Remember that origin is just going to select the origin column. Count star is going to select the count of the number of rows that are being returned from my flights table and group them by origin. And so what that's going to say is group by is going to say take all of the rows and put them in groups based on their origin. So all the flights that are from Moscow go in one group. All the flights from New York go in another group. And then count star is going to say, well, count them up. How many of them are there from each of these individual locations? And so select origin, count star from flights, group by origin gives me back something that looks a little like this. I have a list of all of the different origins. I have 5 different origins from which flights are coming from. And then I have this count column, which is telling me how many flights have that particular origin. So in this case, New York has 2, and all the rest have 1. And so what if I wanted to select only the origins that have more than one flight going out of it? I want to select the popular places from which people are flying. And my definition of popular in this case is it's going to be a flight that has, or a location that has multiple flights coming from it. So I can say select origin, count star from flights, group by origin, same as before. But after a group by, you can optionally specify what's called a having clause, which is similar to a where clause, except it follows the group by. So I group by origin, but I only want to select those origins that have what particular property? Well, I want to select the ones that have count star greater than 1. So to break down this query, it's a little bit long. I'm selecting the origin. Just this is going to be a list of locations. Count star, this is how many flights are from that location, from my flights table. Grouping them by origin, this is how I get all the New York flights together, for example, and all the Lima flights together. And then having count star greater than 1 is going to mean I only want to get the origins that have a count of greater than 1. And so the only thing that I get back from that query is New York, which in this case has 2 flights coming out of it. So that would be how I might do a more complicated query to get back particular information that I care about. Questions about how that worked? OK. Next up, we're going to talk a little bit about foreign keys. So a foreign key is going to be a way that a method that we're going to use in order to connect multiple tables together. And so SQL is often called a relational database. And it's called a relational database because one thing that makes it quite powerful is the ability to take multiple different tables and relate them together in some way. So you imagine that I have a flights table, for example, that's got an ID, origin, destination, and duration, just like we had before. But you might imagine that as my airline application gets a little more complicated and I add more features to it, I might start to need more out of this application. I might, for example, want to keep track not only of the name of the place I'm flying from, but I might care about the airport code of that particular location. So I've just picked out a representative airport code from each of these individual cities. And so New York, I've picked JFK, and each of these different origins has an origin code, and each destination has a destination code to tell me which specific code represents the airline that I'm flying out of or flying into. But now, as this starts to get more complicated, you can start to see some of the potential design improvements that we could make to this table. In particular, notice that I've repeated a whole bunch of data. For instance, I specified here New York, JFK, and here is also New York and JFK. And therefore, there's a lot of redundancy here. And it might be nice if I could treat this information as separate. If I could say, I want to keep track of locations as its own entity, and then I want to keep track of flights that are somehow related to locations. So I keep track of a table of locations, or places, and then I keep track of a table of flights where my flights somehow know about that table that contains New York and Shanghai, et cetera. So what I might do is define a table called locations that looks something like this, where each one has an ID, each one has a code, and each one has a name. This is just like the stuff we've seen before, except now I have a table exclusively just for representing individual locations. And then what I would do in my flights table is instead of having an origin column and a destination column, I'll have an origin ID column and a destination ID column. These columns technically could be called anything, but by convention, it's something underscore ID to mean this is the ID of the origin of this flight. And which flight or what location has ID number 1? Well, I could go back to this locations table. Here's the thing that has ID 1. OK, this flight must be flying out of JFK in New York. I go back to my flights table. Where is it flying into? Its destination is 4, destination ID 4. So all right, go back to the locations table. Here's the thing with ID 4. That's London. So you can begin to use these numbers just to represent locations. That way I don't need to have New York, JFK, New York, JFK repeated over and over again inside of my table. I just need to have an individual number to represent here's the location that I'm flying out of. Now this might seem harder to read. In particular for us humans, looking at this, this is perhaps even less clear than the table was before if I want to figure out like where is this flight flying from and where is it flying to. Now I need to take this number 3 and look it up in a different table. But SQL databases are actually quite good at dealing with this. And this is where they really excel and thrive, is having these relationships between tables and being able to connect them in a way that's meaningful. Questions about this general idea of what we're trying to go for here? And you can imagine extensions that we could make to this. If I wanted to keep track of passengers on individual flights, well, then I might have something that looks like this, right? Each passenger also has an ID. Each passenger has a name. And each passenger has a flight ID, namely the ID of the flight that they are a passenger on. And so I've got 2 people registered for flight number 1, 2 people registered for flight number 2, so on and so forth. Questions about what we're going for? Yeah? It can be used. So the question is, why would we be using this relationship? Certainly, we can be using it to save space, because now I don't need to, if I have long pieces of text, I don't need to have them appearing multiple times throughout the table. I can just have it appear in one row and then reference it by a number in some other table. And the other advantage is that it helps to keep things organized. In particular with passengers, you can imagine if we only had this flights table as we had it before, where all of the flights had origins and destinations, it would be pretty tough now to, in this same table, keep track of passengers. Right? There's no easy way to add like a column for a passenger, because there might be multiple passengers, for instance. And so it makes a lot more intuitive sense to say, flights are one type of entity. We'll keep track of that in one table. Passengers are a whole different entity. Let's keep track of that in a different table. But there's relationships between the tables. Each passenger is associated with one flight. And so that's what the flight ID on the passengers table is ultimately going to be used for. Good question. So let's take a look at how that might actually work in terms of how we would go about creating foreign keys. And a foreign key is just a fancy way of saying we're referencing the key from a different table. So my flight ID column is referencing the primary key of that flights table. So what I might do is create a table, and I'll call it passengers. And my passengers table will have an ID, which will be a serial primary key, just like the other table. It'll have a name for who the passenger is, and that should be text varchar, not null in this case. And then finally, a flight ID, which is going to be an integer that references the flights table. In particular, flight ID is going to be an integer that is going to reference the ID of whatever is in the flights table. So I'm linking these 2 tables together effectively. And so now I've created that table as well. So I'm going to go ahead and I have a couple of these insert lines. These insert lines are just going to add a couple passengers into my table. So notice I'm inserting into passengers, inserting a name and a flight ID, and their values are just their name and the ID of the flight that I'm adding them to. So I'm going to insert all those. And now if I select star from passengers, you'll notice that I have 7 rows. Each one of them is an individual passenger, and each one is an individual flight ID. And so I can see, OK, let's say I wanted to know what flight is Alice on. So I could say select star from passengers, where name equals Alice. And I get, OK, Alice is on flight ID number 1. And so now I want to say, OK, what's flight ID number 1? Select star from flights, where ID equals 1. OK, Alice is on the flight going from New York to London. And that would be my answer. But in order to do this, I had to do 2 queries. Right? I first queried the passengers table to say, what flight number is Alice on? And then I query the flights table to say, all right, which flight has ID number 1? And it would be nice if I didn't need to do 2 queries, if I could join these 2 queries into one. And in fact, in SQL, you can, using a special type of syntax called a join. And joins are very useful once you start dealing with multiple tables, because what a join allows you to do is take 2 different tables that are related in some way and group them together in one when you try to select from them. So what might that look like? Well, what I'm going to do is I want to select now from my passengers table and my flights table simultaneously. And in particular, I want to select from those tables under certain conditions. I want to select maybe the origin of the flight and the destination of the flight and the name of the person that's flying. So origin and destination are both columns of my flights table. Name is a column of my passengers table. These are two different tables that I'm selecting information from now. So I'm going to say, OK, let's select this from my flights table. But I want to join this with my passengers table. So I'm selecting the origin, destination, and name. Those are the columns I care about from the flights table, joining that with the passengers table. But the last step is telling my query how these two tables are related. I need to tell my table in particular, my query in particular, what do I want to join them on? What is the relationship between these two tables? And in particular, the relationship here is that passengers, and I'm going on to a new line, but this could all theoretically be one line, passengers.flightID equals flights.id. So I'm joining the flights and the passengers table and saying join these two tables together, and here's how they're related. If you take the passengers table and get the flight ID column, that should match the ID column of the flights table. And so I press return, and this is what I get back. I get back Alice on the flight from New York to London, Bob on the flight from New York to London as well. And so I get back all of these rows from two different tables that have now been matched up, that have been grouped together into a single table. And so if I wanted to find out what flight is Alice on, for example, I might reasonably do the exact same thing as before. Select origin, destination, name from flights, join passengers on passengers.flightID equals flights.id, where name equals Alice. And that will tell me that Alice is on the flight from New York to London. Questions about that join syntax and how that worked? So it was how we were taking two tables and combining them together. Yeah?
I actually have a backup on the reference when you say the reference when you're defining the table, the passengers table. When you insert it, if you would put some ID that was illegal, would this row not go in?
Good question. So what is this references keyword doing? What is it specifically doing? And yeah, it helps. What it ultimately helps to do is it helps to enforce constraints to make sure that I can't do something wrong, for instance. So if I try to, so Alice we just saw was on flight number 1, right? So if I now try to delete from flights where ID equals 1, what I'm going to get back is an error. And the error that I get back is that key ID 1 is still referenced from table passengers, for instance. So something in the passengers table is referencing flight ID number 1, and therefore I can't delete the flight that has ID number 1 because that would result in a violation of that constraint. So it does, the references keyword is used to help us enforce that type of constraint so that we can't do something wrong. If I try to delete a flight while there are still passengers registered for it, the database will physically stop me from being able to do that. Good question. Yeah?
Is there a connection between flight ID and IDs that's sort of implicit in MySQL?
So OK, the question is the relationship between flight ID and ID implicit? So generally speaking, when we use the references keyword, we are referencing the primary key of some other table. So because in the flights table, I said that the ID was the primary key, the main thing that I'm going to be referencing that table by, it assumes that, yes, I mean the ID column of the flights table is the thing to reference. There are ways to specify a different column that you want to reference instead. But generally speaking, the references keyword is almost always used with referencing an ID of a different table. Good question. So what we saw just now was an example of a join. And the way that that join worked was it took two different tables, and it, based on a particular condition, matching up the flight ID of the passenger with the ID of the flight, was able to find all the matching rows and give me them back. But what you noticed in that query was that if I go back to it, what I get back are only the matches. In other words, I get back only the origin and the destination and the name, where there was a match between the name of the passenger and the flight itself. But there might be flights that have no passengers, for example. And so there are different types of joins. The join we just did was called an inner join. And in SQL, when you just specify the word join without specifying what type of join, it assumes that you mean an inner join. In other words, only get the things that match. You also have the option of doing what's called a left join. So what left join is going to do is it's going to take the table on the left, in this case the flights table, and it's going to make sure that all of the rows in the flights table are included in the final result, even if they don't have a match. So if I left join flights and passengers together, what I get back is this. which is the first 7 rows are the same as before. It's the result of that direct matching. But I also get back the flights that didn't have a match. In particular, Moscow to Paris doesn't have any passengers on it. Istanbul to Tokyo doesn't have any passengers on it. But I still get those rows back as well. And likewise, there's an equivalent right join that selects all of the things from the right table, even if there are no matches on the left table, where the left table is just the one that comes first. So those are different types of joins, and those can be used in order to help to combine data coming from different places. A couple other things we'll say about SQL, and then I'll take a brief break. So joins, we talked about different types of joins. Another thing that's frequent in databases, especially as databases get large, are indexes. And what an index is you can think of an index like an index in a book, for example. It's an easy way that if I'm looking for something, I can quickly reference something else. And so what you can do in SQL is add an index to a particular column to say that if I'm going to be referencing flights by their origin a lot, it might be helpful if I add an index of the origin of all of my flights. Some way that I could very quickly say, if I want to look up all the flights from New York, I just go to New York in my index and look up all the flights from New York and make that faster. So I can create an index on an individual column, and the syntax for that is just create index followed by the name of the index, which can be an arbitrary name, and then what table and what column you want to create an index on. And what that will do is it will speed up anytime you try to select from that table based on that particular column. So if we have this way of creating an index that just makes it easy to look up a particular value from a column and go to it immediately, or go to it much more quickly than you could otherwise, why wouldn't we just create an index on every column? And can anyone think of reasons why we might not do that just to every column? Yeah?
Instead of creating a new table under the hood, with the priority key being the column that you mentioned, would it take a lot of space maybe?
OK, great. So space is one potential concern. That creating the index does, in fact, take up space. And the other potential concern is time. That while creating an index on the origin column, for example, of my flights table, might make it faster to look up a flight by its origin. If I want to look up New York, all flights from New York, I can easily look that up. What it'll do is it'll actually slow down things like updating data or inserting data. Because if I now insert a flight from New York, for instance, it's not as simple as before. I can't just insert the flight into the table. I need to insert the flight into the table and then go into the index and update the index so that if I look for New York again, I'll be able to find it more easily. So it's a trade-off there, and just one to be mindful of, that as data gets big, it can often be helpful to add an index to your table in order to make it faster to look up that data. But the trade-off, the cost there is A, space, but B, some time in terms of the time it takes to update that data or insert that data as well. One final thing we'll take a look at before we take a brief break are nested queries, when we try to combine multiple queries together into one beyond just what we've seen before. So we saw before we had a flights table with each column ID, origin, destination, and duration. We had a passengers column where each passenger has a name and a flight that they're associated with. So if we look at a query like this, this is a relatively on the more sophisticated side of queries that we've seen so far. Select flight ID from passengers, group by flight ID, having count star greater than 1. Any guesses as to what that query is going to do? It's all syntax we've seen before, but take a moment to look at it, think about it. What is this query going to do when I actually try to run this on the passengers table, which is right here? So each passenger has an ID, a name, and a flight ID. Thoughts on what will happen? Yeah?
Select passengers with more than one flight.
Good thought. So selecting passengers with more than one flight is very close, although not quite. Other ideas?
They want flights that have one.
Exactly, yeah. So what we're doing, since we're grouping by flight ID, we're saying take all the passengers that have flight ID number 1, put them here. Take all the passengers that have flight ID 2, put them here. Group them based on their flight, and then count them up. And so in particular here, we're going to only be selecting flight IDs when that flight has more than one passenger on it. And so the result that I'll get is a table that looks something like that, because flight IDs 1, 2, and 6 are the only flights that have more than one passenger on it. But what if then, so now I've created this syntax, select flight ID from passengers, group by flight ID, having count star greater than 1, which is this long syntax that means get me all of the flight IDs for flights that have multiple passengers. What if now I wanted to select all of the flights themselves that have multiple passengers. I want to select from my flights table, but I want to select from the flights table only on the flights that have more than one passenger. Well, I can begin to nest these queries within each other. And this is where SQL starts to get a little more complicated. I can say, well, if this is the query that gets me all of the flight IDs that have multiple passengers, well, let's try this query instead. These two lines are the same, but wrapped in parentheses. But now I'm going to select star from flights where the ID of the flight is in the result of this query. So this query, these bottom two lines in parentheses, those were the lines that were saying, get me all the flight IDs that have multiple passengers. And this top line up here is saying, select everything from flights, all the columns from flights, as long as the ID of the flight is in the result of this query, where this is the result of the query. So what's going to happen is if I select flight star from flights, where ID is in the result of this query, these are the rows that get selected, 1, 2, and 6, because those are the flights that have multiple passengers on them. So if this starts to get confusing, I usually recommend just breaking it down into one query at a time. First, take a look at these two lines and make sure you get a sense for why is it that these two lines are giving me this table, the one that has just the flight IDs with multiple passengers on them. And once you have that in mind, if the result of this is just 1, 2, 6, then this big query is really just saying select star from flights where ID is in 1, 2, and 6, where the ID is one of those three, where we got those three based on running the second query. And so SQL allows you to nest these queries together to begin to do more complicated things, to combine multiple queries into one, to get really just the data that you care about by relating multiple tables together. We'll take a quick break, and when we come back, we'll talk a little bit more about SQL and dive into how we actually use this inside of a web application using Flask. OK, welcome back. So right now what we'll do is we'll take a step back from the syntax of SQL. We looked at how we would go about creating tables and inserting rows into tables, selecting rows from tables using a whole variety of different syntaxes, including joining multiple tables together. And we'll talk about a couple of security considerations that should be going through your head as you think about how to interact with databases. And after that, we'll dive into actually using SQL to build them into the Flask web applications that we started building last week and see how we can use SQL to leverage them to be quite a bit more powerful. So the first thing that we want to talk about is SQL Injection. And so the context for this is imagine that you're running some website, and that website allows users to log in. You've got some form on your website that has a username field and a password field, as many websites do that just let a user type in a username and password and log themselves in. Now start to think, once a user submits that form, what sort of SQL command might you be running in order to verify whether or not that user is actually successfully logging in? How might you go about doing that? If you had imagine you had a table that had all the users in it, that had usernames and passwords, for instance, what type of query and what would it look like? Yeah, it's going to be some kind of select query where I'm probably selecting from the database. In fact, it might look something like this. Select star from users, where username is, and I've highlighted this in yellow to mean this would be just substituted in for whatever they type in. Username is their username, and password is password. And so you might imagine that if the user typed in their username and password correctly, well, then there's probably going to be a row somewhere in that table that has a matching username and has a matching password, and therefore the select will return that row. And if the user didn't input valid credentials, either because the username didn't exist or the username did exist, but they typed in the wrong password, then the result of this query would be that no rows got returned. Of course, in reality, the query probably doesn't look exactly like this. For security reasons, most databases will not store the actual password of a user and will instead store a hash of the password. But more on that a little later. But you imagine that the query is going to look something along these lines. So if a user comes along, they type in username is Alice, password is 12345, then the query that ultimately gets run is going to look something like this, where username and password are substituted in for Alice and 12345. So I'm selecting from the users table where the username is Alice and the password is 12345. So if Alice is indeed in the database and her password is 12345, then this select query will return that row. And if either of those things are wrong, then it won't return a row. But now imagine what happens if a hacker is trying to hack into my website, is trying to do something malicious, and guesses that maybe the SQL code that I'm using looks something like this. Maybe I'm running a SQL command like select star from users, where username is something and password is something else. And a clever hacker might be able to do something like this, where in the username, they type in hacker or whatever user they want to get access to. And in the password, they do something strange. They type one single quote or single quote 1 single quote equals single quote 1. Now this seems sort of strange. Why would anyone ever type this in as the password? But let's go back to the SQL query and look at what actually happens now when we try and take this username and password and try and run it through our database. Well, what will happen is we select star from users, where username is the username and password is password. And if we plug in hacker as the username and 1 single quote or single quote 1 single quote equals 1, well, the result of this as interpreted by SQL might reasonably be select star from users, where username is hacker, or whatever username the hacker is trying to get access to, and the password is 1, or the string 1 equals the string 1. Well, of course the string 1 equals the string 1. Those are the same thing. So it doesn't even matter what this password is. It's still going to return back to the user with that matching row, even if the user didn't get the right password, which in this case they didn't. And so this is an example of what we call SQL injection. What happens is if we're not careful about the way that we run our queries, and we let some user potentially input arbitrary SQL commands, they could potentially take over what SQL code is running just by allowing the user to type something in and using that input directly inside of a SQL query. And so in this example, SQL injection can be used to get access to someone else's user account. But you might imagine an even more malicious situation. You could imagine that we talked before about how if you do like an update something from a particular table, and you don't specify what's being updated, it could just update all of the rows in the table, or likewise, you could delete all the rows of a table or delete a table altogether. If you let users just type something in, and you take whatever they type into a form and run it as SQL code, then a user could theoretically type in whatever SQL they want and manipulate your data however they like, delete your data however they like. So this is a pretty significant security concern that you want to be thinking about. And so what's the solution to this? Well, in SQL, you can do what's called escape particular characters. So if the password actually has a single quotation mark in it, you don't want it to be interpreted as the end of the password itself. You want it to be interpreted as the single quotation mark character. And in SQL, you can do that by, I think it's doing two single quotation marks in a row back to back, just to mean this should be an actual single quotation mark and not the end of the password field. But ultimately, the long story short of this is that we want to come up with ways that allow us to avoid this type of problem. Rather than just directly substituting user input into the query, we want to be intelligent about it and make sure that we are escaping or sanitizing our input, as it might be called, in order to make sure that we don't run into situations like this. And so in a moment, when we transition into looking at actual Python code and how we can use that Python code to be able to run SQL queries, this is something we're going to be keeping in mind. Because if a user is ever typing in information, we want to be careful not to just plug it directly into the query. We want to make sure that we don't run the risk of SQL injection there. But questions about SQL injection and why this has the potential to lead to a security risk? OK, one other thing related to SQL that's worth talking about, especially with security, is the idea of race conditions. And so a race condition comes about when there's a possibility that you've got a database somewhere that's potentially accessed by multiple different people, and you run the possibility of things going wrong if people try to do things at the same time and operations execute in a funky order. And so what do I mean by this? Well, imagine that I've got a database that represents a bank, for instance, where I've got a bank database where every row is an individual person who has an account at my bank, and we have a column representing how much money they currently have in the bank. So imagine that I've got some data in my bank account. The data is storing that right now this particular user has $100 in their bank account. And the person goes up to an ATM somewhere, and they try to withdraw $100. Well, if you are running the bank's database and a user tries to withdraw $100, what's probably the first query you should run on this database? Doesn't have to be a precise query, but what would you want to know from the database if user says, please withdraw $100? Do you have $100? Great question. So what might that look like in terms of a SQL query? Select balance from bank where user ID equals 1. Here I'm assuming I've got a table called bank that's got a column called user ID representing the user and a column called balance. So imagine that I have that. So imagine that this current user ID is user ID number 1. And I want to select the balance from the bank to make sure that whatever balance I get back, it better be at least $100. Otherwise, I don't want to let you withdraw $100 from the bank. So I run the query. And right now in the bank account, I have $100. So the SQL query gives me back 100. We're all set. Next thing that happens is that I actually get the $100, but what query needs to run now on this on this table? Updating, exactly. So I want to update the bank, setting the balance equal to balance minus 100, where the user ID is equal to 1. So I update the bank balance. I want to decrease the balance by 100. That's what the set is doing. And I don't want to decrease everyone's balance by 100. I only want to decrease by 100 for user ID number 1. And so I get the $100 back, and my bank account balance goes down to 0. And that interaction seems fine. I selected to make sure I had $100. Then I updated the bank to make sure that it reflects my new balance. But what now happens if two people, for some reason, are going to different ATMs, but they both have my ATM card? They're both using the same ATM card, and they're going to different ATMs. And they're doing this at the same time, and they're both trying to withdraw $100. What happens? So you might imagine that if they both press withdraw at the same time, same thing will happen on the first ATM, right? I need to make sure that I actually have $100. Select balance from bank where user ID is equal to 1. Do I actually have $100? Well, yeah, I've got $100. But then person over here on ATM number 2 is doing the same thing. They're running the same query. They're also selecting a balance from the bank where user ID equals 1. And maybe this is happening a split millisecond after that first select query happened. But it doesn't matter. There's still $100 in the bank, and so this still gets me back 100. So what happens now over here on side number 1, maybe right after this happens and right after that happens, now we're running our update. We update the bank, set the balance equal to balance minus 100, where user ID is equal to 1, same as before. And same as before, I get the $100 back, and my bank account balance goes down to 0. But then the problem comes in over on this side, because we decided that the way to withdraw money from the bank was a two-step process, right? Number 1, select, make sure you've got $100. And if you do, then fine, update in order to subtract the $100 and then give the user $100. From the perspective of ATM number 2, I've just selected, and I have $100. So we're all set. ATM number 2 thinks it's totally fine to withdraw. So ATM number 2 runs update the bank, decrease the balance by $100, where the user ID is number 1. ATM number 2 gets back $100, and the bank account goes down to negative 100. But now from a bank account with $100, I've managed to extract $200 from it by taking advantage of race conditions, by running things simultaneously. And even though the logic of select, make sure I have the money, and update feels like it's the right logic, when you consider what happens when there's concurrency, when multiple things are happening at the same time, these are the sorts of concerns that begin to take place. So what's a solution to this? How do we solve the problem of dealing with multiple people that could be using the database at the same time and trying to prevent something like this, where someone can get $200 from the ATM when they only have $100 in the bank? Transactions, exactly. And so the idea of a transaction is that I want to, or the idea of it's transactions and the idea of locking the database, that I want to lock the database first to make sure nobody else can touch the database while I'm running a transaction, a sequence of SQL commands. And so that way, I can say, all right, I'm starting a transaction now. Nobody else touched the database. Let me select the balance, and then let me update the bank. And now that I'm done with the transaction, now you, ATM number 2, feel free to go ahead. And then everything's fine, because when ATM number 2 gets a chance to go to the bank account, it's at 0. And so the select query is going to return a 0 instead of 100. And so the syntax for that in SQL transactions are, if you type begin followed by a semicolon, that begins a transaction. And then all of the commands that you run are executed effectively together as a unit. And then at the end of the transaction, you say commit to say, these are the commands I want to run. Go ahead and run them. And so that is a way that we can begin to group these things together. So the idea of race conditions, the idea of SQL injection, these are just good security considerations to be taken in mind as we start to approach designing databases that are ultimately going to go into our web applications. But now, how do we actually take these databases and put them into our web applications? Last week, if you recall, we explored Flask, which was a micro framework written in Python that let us pretty easily get a web application up and running in Python that had a whole bunch of routes that we were able to use in order to direct users to different pages depending on what site they visited. What we'd like to do now is bridge the gap between Python and SQL to allow our Python code to be able to run SQL commands on databases. And so what we'll be using for that is a popular library called SQLAlchemy. SQLAlchemy is a Python library that is used to connect Python and SQL, to connect these two worlds and to allow Python code to be able to run SQL queries. And so we'll take a look at that right now. So let's imagine that I want to run, and for now we'll start with just command line programs, programs written in Python that don't yet live on the internet. But in just a moment, we'll transition to looking at web applications as well. But imagine for now I just want a Python program that prints out all of the flights that are currently in my flights table. What might that code look like? Well, let's go ahead and look at list.py as an example of this. And so what we have up here are a couple of import lines. So import OS is just importing an operating system library that's going to have a useful feature that we'll see in a moment. And then I'm importing a bunch of names from SQLAlchemy, which is the library that we're going to be using to interact with databases, create engine, scoped session, and session maker. I'll briefly describe what these are doing, but don't worry about them all that much. What's happening effectively is on line 6, I'm creating a database engine. The engine is just, think of it as an object created by SQLAlchemy, this third-party library that we're going to be using, that is used to manage connections to the database. The engine is going to take care of for us the process of talking to the database and making sure that Python is able to send commands to the database and get results back from the database. Instead of us needing to worry about that database, the engine is going to take care of that for us. So on line 6, I say create engine. And then here, I have os.getenv database URL. Last week, if you recall, we talked briefly about the idea of environment variables, variables that exist inside of my terminal environment. We saw that for setting like Flask app or Flask debug. The environment variable in this case is just going to be some variable that's set in my terminal, the same place where I'm running Flask or running this program. And in this case, I'm specifying in an environment variable the database URL, the URL of where my database lives. In my case, that URL is localhost, my own computer. But if you've got a database that's living somewhere else on the internet, that might actually be a URL. And when you start working on the next project and start working with SQLAlchemy, we'll give you one of these URLs that you can use as your database online. On line 7 now, what we're doing is we're creating a scoped session. And so this is less relevant for this particular example, but you imagine that once we take our web application to the internet, and we have multiple people that are simultaneously trying to use our website at the same time, we want to make sure that the stuff that person A is doing with the database is kept separate from the stuff that person B is doing with the database. And so creating different sessions for different people is just a way of managing that. But ultimately, now we have this object called db, which is going to be the one that you're really going to care about, because that's what's going to allow us to run SQL commands. And this code will all be included for you in the project, so you won't need to worry about rewriting that. So what's happening in the main function of my code now? Here's what's happening. On line 10, I say flights. I want to query for all of my flights. So how do I do that? I say db.execute. And then in quotation marks, I can specify whatever SQL command I want to run. We just talked about SQL syntax. Here, just as a string, I'm going to feed in SQL syntax into db.execute to say I want to run all of this SQL code. In particular, I'm selecting origin, destination, and duration from flights. Those are the 3 columns I want to select from my flights table. I want to select them all. And then at the end, I'm doing this fetch all query, which is just to say run the query and get me all of the results. There's likewise a fetch one function that just gets me back 1 row if I only care about 1. But in this case, I want to get back all of the flights. So I'm saying db.execute. Here is the SQL command I want to run, the select query we saw just a moment ago. And then fetch all says get me back everything. So now I have inside of this variable flights a list of all of the individual rows that came back from that SQL query. And so now on line 11, I'm running a loop. For flight in flights, I'm going to print out this formatted string, flight.origin. That's going to get me the origin of this individual flight, because I can use each individual flight, each row, and to get at a particular column, I use the dot notation. So flight is the name of one of those individual rows. To get just the origin of that row, I'll use flight.origin. So I'm printing out flight.origin to flight.destination. And how long is it? Flight.duration minutes. And that's all that's happening. I first run a query to say, select me all the data from the flights table. Then I run a loop. For each individual flight that I get back, print out that result. And so now, if I go ahead and run list.py, what I get back is 1 per line, New York to London, 415 minutes, Shanghai to Paris, 760, so on and so forth, giving me all of the data coming back from those individual flights. Questions about the syntax of how that code worked? That was me using queries to select, yeah. Does it always return as a list? If I use this fetch all command, that is how I get it back as a list. Fetch all says, get me back all of the results from the query and give it back to me as a list of all of these individual results. Good question. So that was selecting data from my database. One thing we might also want to do using Python code is importing data, inserting data into the database. Because if you remember from before, when I wanted to insert flights into my flights table, I had to use syntax like this. I had a whole bunch of these insert queries, each one of which was saying origin, destination, value. Here are the values of the things to insert. But generally speaking, if I have a whole bunch of flights to insert, it's not going to be nicely formatted like this already in SQL query form, ready to be inserted into the database. Likely, it's just going to look something like this. This is flights.csv. So CSV stands for comma-separated value, just an easy way to represent data. And I'll likely have data that looks like this. It's just one row for each flight. And instead of it being formatted nicely as insert into something, it's just the origin, comma, the destination, comma, a number of minutes. And that's all I have to deal with. And so if I just give this to SQL, SQL doesn't immediately know how to understand a CSV, though you can tell it to try to import it from a CSV. So what I might want to do is write Python code that reads this CSV file and takes each row and inserts it into my table. So what might that look like? Let's go into import.py and look at what's happening here. These first couple lines are really the same. But here's the interesting activity. And again, this code will be made available after. So if you're interested in importing data into a table as well, which you'll need to do for project 1, you can use this as a reference or a guide for how to go about doing that. So on line 11, I'm opening up this flights.csv file. That's the file that contains all of my flight data. So I'm opening it up, and I'm calling it f. And Python has a built-in module called CSV, specifically meant for reading and writing CSV files. And so I'm going to use csv.reader, which I only know about because I've looked up CSV reader's documentation online. And I'm saying, I want to read file f as a CSV file. And now on line 13, what I'm saying is I'm looping over this reader. I'm looping over every single line that the reader is going to read. And for each one, the 3 columns are origin, destination, and duration. So I loop over the reader, and I'm going to, for each row, call the first column the origin, call the second column destination, call the third column duration. And for each one of those rows, what do I want to do? Well, I want to do a db.execute. But instead of a select like I did last time, I want my db.execute to be an insertion. And so what does this insertion look like? I'm going to insert into flights, origin, destination, duration, values. But notice that when I'm at the time that I'm writing this code, before I look at flights.csv, I don't yet know what values I want to insert into my database. I don't know if the flight's coming from Lima or Shanghai or wherever. All I know is that I want to insert some origin, some destination, some duration, and I want to fill in those blanks later. And so SQLAlchemy supports the idea of placeholders for this purpose, where I can say values and colon origin means this is a placeholder for the origin, meaning something is going to go in that spot, but I don't yet know what it is at the time that I'm writing the code. I'll only know when I run the code and I actually read that flights.csv file. So colon origin means this is a placeholder for the origin. Colon destination means this is a placeholder for the destination. And colon duration means this is a placeholder for the duration. And then to fill in those placeholders, what I do immediately after it, this could be one line, but I've broken it up into 2 just for clarity. After a comma, I'm providing a Python dictionary, which is this right here, that tells the query what to fill in to each of those individual placeholders. So in the origin placeholder, fill in origin, where this origin is this variable over here that I read from a row of my CSV. And likewise, I'm filling in the destination placeholder with this destination, and the duration placeholder with whatever the variable duration is. And if it makes it clear, I can just call this like O and destination and duration, just to signify that these are just variable names, the things after the colons. They're whatever variables I'm using. But these things in quotation marks, these are the placeholder values that I'm filling in for. This origin, destination, and duration correlate with this origin, destination, and duration. Those are the placeholders. And then immediately after it, I specify, all right, now fill things into those placeholder spots. And then afterwards, I'm just printing a line that says I added a flight from origin to destination lasting duration minutes, just so I can keep track of that for myself. And then at the end, SQLAlchemy automatically does this kind of transaction thing for me. It automatically says, you know what, let's assume you want to group all your actions together. And then at the end, you better just say you want to commit those changes. And so at the end, I need to tell my database db.commit, meaning save the changes that I just made. I didn't need to do that last time because I was just reading data from the database. I didn't actually update anything. But now that I'm inserting rows into the database, SQLAlchemy wants me to, at the end of all my inserts, say, all right, now I'm done, commit these changes, actually run them. And so this is similar to the commit that we saw a moment ago when we were talking about race conditions. So let's try and run that now. If I try and, so right now if I run Python list.py, that gives me the 6 flights that I've had inside my database this whole time. But now if I run Python import.py, what that's going to do is it tells me, all right, I've added all these individual flights, Paris to New York lasting 540, Tokyo to Shanghai lasting 185 minutes. And these are all the flights from this flights.csv file, where each row corresponded to a flight that I wanted to insert. So now if I run Python list.py again, what I get is a longer list of flights, because now I've added all these additional flights to the database. Questions about that import process or how that worked from the CSV file? Yeah?
Is it synchronous? Is SQL synchronous or asynchronous, whatever?
Good question. Is SQL synchronous or asynchronous? In what context do you mean?
Like if you did this DB commit, if you didn't do the transactional strategy with other things, if you do like a really long SQL query, and then someone else does a really short one, if you start that query, will no one else be able to access your database?
Oh, good question. So what happens if you have a lock on the database, you're running things, but someone else is running something short? Generally speaking, if you've locked the database, nobody else can get access to it. So they cannot get in there while you're in the middle of running those individual queries. Repeat that?
If you don't lock it?
If you don't lock it, then there's no guarantee on what order things are happening in. So something else could theoretically come in and run commands as well. Yeah?
So once you do the .execute, does that lock the database?
Good question. So what happens after I run db.execute relative to db.commit? I don't actually start running these commands until the db.commit happens. What happens is that effectively SQLAlchemy is keeping track of all the changes I want to make, and it's not until I run db.commit that we actually go ahead and run the actual queries in the database to make those changes. Good question. So this is the code that will allow me to import. The result of that is that I've imported all of these flights here. And so now let's look at something a little more complicated. Let's look at an example where I want to do a combination of multiple different types of queries all happening within the same Python program. We'll just look at this briefly. This is passengers.py. And what this is going to do is it's going to give me a text-based way of looking up what passengers are on a flight. And so I'll just briefly go over at a high level what's going on here, and then you can look at this in more detail later. But effectively what's happening is that in my main function, the first thing that I do is execute this command, select ID, origin, destination, and duration from flights, meaning get me all the columns from the flights table, save it inside of this flights variable, this list, then loop over that list, and for each row in my table, for each element in the list, go ahead and print out that flight data. Flight ID, origin to destination, lasting duration minutes. So that will do much like we did in the list example, just print out one thing per line. But now let's imagine we want a program that lets the user say, all right, flight number 5, tell me who's on it. So what happens next is I can prompt the user for input using that input function and convert that input to an integer, just so it's a number, and save that result as a flight ID variable. So I'm just going to ask the user, type in a flight ID. I type in flight ID 28 or whatever, and that saves it inside the flight ID variable. And now I'm going to run another execute query, which is that I'm going to select origin, destination, and duration from flights, where ID is :ID, this placeholder, where that placeholder is going to be filled in by flight ID. And here I'm just fetching one thing. And so the long story short of what that's doing is it's saying, all right, whatever number you've typed in, let's just query the flights table again and make sure that there actually is a flight with that ID. Right? If I type in flight ID 255 and there is no flight 255, then this fetch 1 is going to return back nothing, or none, because no flight matched that query. And so if the flight is none, if there was no flight, if it was an invalid flight, it'll print error no such flight and just return and quit. But otherwise, if the flight was a valid flight ID, then I'm going to get the passengers. So I run a db.execute that says select name from passengers where flight ID equals whatever the flight ID is, and get me all of those rows. So get me the names of all the passengers. And then for each passenger in that list of passengers, I'm going to print out that passenger's name. And if there were no passengers, I print out no passengers. So what does that look like? I run python passengers.py. It prints out all my flights, giving me their ID, their origin, their destination, and how long. And if I want to know, who's on flight number 2, I type in flight 2, and then it says, OK, here are the passengers on flight 2, Charlie and Dave, by running those individual queries. So first, it queried for all the flights. Then I typed in a flight ID. And based on that ID, it queried for the passengers table, getting me all the passengers that are on that flight as well. Questions about how we did that, generally speaking? OK, so we've gotten a sense for SQLAlchemy and how we can use it to actually run commands, SQL commands in Python code. Now let's make the next leap and say, all right, how do we take that and merge it in with one of our Flask applications so that our web applications that are living on the internet that people can go to a URL to and look for, how can those be using SQL databases as well? So the example we'll take a look at here is Airline 0. And this is a Flask application. So what we do is we have a Flask application just like before, but we also are setting up a SQLAlchemy engine and a SQLAlchemy session called DB that we're going to be using. And what's happening inside of application.py? Well, in my index function, this default route, recall that this is just what happens when the user goes to the / route on my website and just wants to see the website. It runs this function. And here's what happens in my index function. First, I query for all the flights. I say db.execute. Select star from flights, dot fetch all, just get me all of the flights, and then render the template index.html, where flights is equal to flights. So I'm going to render index.html, passing in that list of flights, because I want my web page to display those flights, because maybe I'm making a website that lets someone register for a flight, for example. So what's happening in index.html? Well, the first thing to look at is layout.html. This is exactly the same as layout.html from last week, just a simple layout for an HTML website where I've got a spot to put in a title for the page and a spot to put in a body for the page to have as well. And so those are places where I can just insert content. And now let's look at index.html. What's happening here? First thing that's happening on line 1 is I'm extending layout.html. Same as last week, layout.html is this HTML file that is the template from which I want to base this template on. It wants to look exactly the same, except I might fill in something for the title, and I might fill in something for the body. So inside of index.html, now I say, as the title, let's just make the title flights. And then as the body, here's what I want to happen. There'll be a heading at the top that says book a flight, and a form. A form is just going to be a place where users can fill in information. When a user submits the form, let's take them to the book URL. And we'll take a look at book in just a moment. But this is going to be where I'm going to book a flight. And the method for that request is going to be post, because I'm submitting data. And oftentimes when I'm submitting data, I'll submit data via post. Then the key elements inside this form, I've divided into a couple divs just for organizational purposes. But the key here is that I have a select here. And a select is just a drop-down menu, a drop-down where you click and you can pick from one of multiple options. And so I'm going to select class equals form control is just Bootstrap's way of styling. Recall that Bootstrap, which we looked at back in lecture 1, is a CSS library that makes our drop-down boxes and buttons and menus look a little bit nicer and look a little more modern. So form control is just a way of telling Bootstrap, this is something I want you to format nicely. And I'm giving it a name, flight ID. And I give this select dropdown a name because later on in my Python code, I'll want to reference it. And when I reference it, I'll want to reference it by its name, in this case, flight ID. What's happening next, on line 14, I'm going to loop through all of the flights. Recall that in application.py, when I rendered index.html, I passed in flights as a variable, meaning flights is going to be a variable that exists inside the index.html template. And so inside of index.html, I can loop over them in a for loop. For flight in flights, for each one of those individual flights, here's what I want. I want an option in that drop-down menu where the value of that option, the value it'll take on if I pick it, is just the ID of the flight. But the text that's displayed in the option is going to be flight.origin to flight.destination. And recall from last week that the double curly braces is a way of me signifying in this templating language, I want to plug in a value here. Flight is the name of that row of the flight that I want to create an option for. And I use dot to get it a specific column. So curly brace, flight.origin means take the flight, get its origin, and paste that into the HTML template right there. And I'm going to do that for each flight in my list of flights. After that dropdown, I have another input. This input is going to be called name. and it's just going to be a place for the passenger to fill in their name. And then at the bottom, I have a button that's just going to say book the flight. So that's all. What's that going to look like now if I go into airline 0 and run Flask run to run this web application? It's running at this URL. And so if I go to this URL now, what I see is book a flight, that big heading at the top. And then I see this dropdown, where this dropdown is populated by the data from my database. Where I click on it, and I see all of the individual flights that are inside my database, because I queried for all of them. And then I looped over each one and made each one an option inside of my web page. And if I look at the page source of this web page, I can see that I've got right here option value 1, New York to London, option value 2, Shanghai to Paris, where the value is the ID of that flight, and then the text of it is just the origin to the destination. It looped over each one of those individual flights, filling in to those placeholder values the values that I actually cared about. And so if I wanted to book a flight, I'd go ahead and click on the flight that I want to book, maybe New York to Paris. I type in my name, Brian, and I press book flight. And it says, success, you've booked your flight. And in fact, if I check that passengers file that I created before, and I check, here's the New York to Paris flight, flight ID number 4. If I type flight ID number 4, who's on it, I now see that I am now on that flight to Paris. So how did that happen? How did that book route work? Because what happened is I submitted a form, and suddenly it said success. What was going on behind the scenes there? Let's take a look at that. So for that, we're going to need to go back to application.py. Because if you recall from index.html, when this form gets submitted, what happens is I submit a post request to the URL for the function called book. And so let's look at the function called book now. I have a function called book. The root is just /book, and it only accepts post requests. So what am I going to do here? The first thing that I'm going to do is use request.form.get, which is my way of extracting information from the form the user submitted. Request.form.get name says take the thing in the HTML form that had a name of name and just get me that information. So I get the name and save that in a variable called name. Now, this is a special syntax in Python called try and except. This is what I do when there's a possibility that something could go wrong, that there might be an error. But if there's an error, I don't want Python to just throw an error and have my whole website crash. I want to handle that error and deal with it in some way. So what am I trying to do here? Well, I'm saying take request.form.get flight ID, whatever that flight ID was, and recall that in index.html, this select drop-down menu, I gave a name of flight ID. So that's how application.py knows this is the select drop box that I'm referring to. So get that result and try to convert it to an integer. If there's a value error for some reason, in other words, if for some reason someone tried to book a flight not to flight ID 1, 2, 3, or 4, but to flight ID foo, or just some word, something that's not an integer, rather than have my whole website crash, which would probably be bad, let's return something nice. Let's return error.html saying invalid flight number, where the message is invalid flight number. And all error.html is a nice error page that also extends layout.html. The title just says error. There's a heading that says error. And then I fill in, using those double quotes, whatever the message happened to be. And so for a generic way to represent an error message, I can create this error.html. And if I want to represent any error now, I just need to return the template error.html, saying here's the message to fill into the error page, in this case, invalid flight number, for instance. So now I have the name. Now I have the flight ID. And now all that I need to do is run a couple of SQL queries. So if you tell me that I want Alice to book flight number 5, the first thing I probably want to do is make sure flight number 5 actually exists. Make sure flight number 5 is a real flight. So let's make sure the flight exists. If db.execute, so I'm running another SQL query, select star from flights where ID is plug in an ID here. What ID do I plug in? Well, I want to plug in flight ID, that variable that I extracted earlier. .row count is a special SQLAlchemy feature that just says, how many rows did you get back? How many rows were returned from this query? And so .row count equals 0 is just going to say, all right, well, that means no flight, 0 rows, had an ID of this flight ID. So what should I do if that's the case, if there were no matching rows? Well, let's also, again, return error.html, this time saying message, no such flight with that ID. There is no flight that has that ID. Sorry, you can't register for it. Now, finally, we've made sure that the flight ID is an integer. We've made sure that flight ID exists. Last step is to run that insert query to say, we've got a person, we've got a flight, let's put them into the table. So I run db.execute, insert into the passengers table. What columns do I want to insert? Well, I want to insert their name, and I want to insert their flight ID. What values? Well, I didn't know yet at the time of my writing the web application. I don't know who is going to register for a flight, what their name is going to be, what flight they're going to register for. I just know they're going to register for something. And so I put these placeholders here, and then I substitute in name for name and flight ID for flight ID. And when I do this placeholder syntax, as a good note, SQLAlchemy will take care of for me automatically the problem of escaping the characters that might cause race conditions. So long as I'm using this placeholder syntax and then using this dictionary to say plug in these values, SQLAlchemy will take care of avoiding those race conditions by escaping any potentially dangerous characters. As opposed to if I just did values like plus name to just join multiple strings together, that would not be safe against race conditions. Because if there were a single quote and some other potentially malicious syntax in the name, that plugging it right into the query just like that would result in me running that query. So you want to be careful never to directly run potential user input into the database unless you're either sanitizing the input yourself or you are using this placeholder syntax that SQLAlchemy gives to us. So we insert the passenger into the database. We commit those changes to say, yes, this is the change I want to make. And then I return the template success.html. And all that success.html is another template that extends from the same layout. The title is success. And in the body, I say success, you have successfully booked your flight. And the result of that is that if I now go back to my web application and I say, you know what, let's take this Hong Kong to Shanghai flight, and I type in my name, and I book the flight, it'll say success, I've booked my flight, and I'm now registered for that flight. So that was a lot of things going on at once. We were talking about HTML, but also talking about Flask and how we go about passing values into templates and then using SQLAlchemy to be able to run database commands. What questions do we have about that and how any of those moving pieces fit together? Yeah?
Should we be using a try-catch for the db.commit too?
Good question. Should you be using a try-catch for db.commit? Certainly that's not a bad idea. In fact, it's probably a good idea from a design perspective to put a try-catch in the db.commit. Because if for some reason something goes wrong as I try to run my SQL commands and there's a problem that gets encountered and that will throw an error, rather than have my website crash, it'd probably be nice if instead it just gave me some sort of nice error message in response to. Another thing that you could also do to deal with that is have a global error handler for your Flask application. So Flask supports the idea of if there is an internal server error inside the application, then return some specific template. And so if you've ever run into like internal server error on a website, that's likely because some part of the code, there was some error in the code, something the programmer didn't anticipate that resulted in something going wrong. And you can have Flask say, you know, if there's an error that's an internal server error, let's handle that by rendering a specific error page. So you can do that as well. But certainly you could put the commit inside of a try-catch too. Other questions?
Well, you should have a try-catch for the name too, right?
So good question. Do you need a try-catch for the name? You probably don't need one for the name, because even if the user doesn't type in a name, the result of this will still just be, it'll just be empty. So maybe you do want to handle that case. Maybe I want to say if name is none, or if name is the empty string, if they literally just typed in nothing, maybe you want to not let someone register for a flight if they don't have a name, for instance. So that can be something you do as well. OK. We'll take a look at one last example before wrapping up for now. We'll look at extending this web application to allow some additional features, in particular, allowing me to see who is currently registered for a given flight, which in reality is probably not information you want made public if you're building an airline website. But for now, we're just going to use it as an example. So before we created a Python application that generated a list of all the passengers, let's do the same thing with a Flask web application as well. So let's go ahead and take a look at airline 1. So inside of airline 1, the index function is the same. We're just going to select the flights, display it for people to register. Book a flight is the same way as well. It works exactly the same. But I've added a couple routes here as well. So let's take a look at this route real quick and see what it does. this is /flights. So if I go to /flights on my website, here's what's going to happen. I'm going to list all the flights. And how do I do that? Well, first, I select star from flights, just select everything from my flights table, fetch all the rows, call that flights, and now return this flights.html template passing in that flights variable. So what's happening in flights.html? Well, the title is going to be flights. Again, it's extending from that same layout file. I'm using that same layout file for all my HTML files to avoid the need to redundantly repeat that HTML over and over and over again. Then inside the body, I have this heading that says all flights, and then a UL. We're calling that UL stands for unordered list. And so I'm going to have an unordered bulleted list of items where each item is just going to be a flight. And so I'm going to loop for each flight in my list of flights, create an LI, a list item, a bulleted item in my list, where that item is an ahref. We're calling that ahref is a link. So I'm going to have a bulleted list of flights, which just tells me the flight. And clicking on any individual flight will link me to presumably another page with details about that flight. It's a common paradigm that happens when you've got a bunch of data, but you want to click on something to go see more information about it in more detail. And so what's going to happen here? Well, the link is going to be itself just labeled as flight.origin to flight.destination, just like we've been using before. But where am I going to link to? If we look back to application.py, I have this other route that's going to be used not for accessing all flights, but for accessing data about one specific flight. And the route I'm using for that is /flights / an integer called flight ID. This is a placeholder that I'm putting into this route that could be substituted for any integer. Recall that in last week's lecture, we talked about how we could use this to say hello to anyone, where you could do /David / Brian / Maria to say hello to a variety of different people, just based on what gets passed into the URL. This is another common use case, where if I want to access a URL for a particular flight, it would be unreasonable and impractical to create one separate route for each individual flight. I wouldn't even know how many to create. Instead, I just create a generic one, /flights / an integer flight ID, that is going to represent accessing /flights /2 for the second flight, or /flights /28 for the 28th flight. And inside this flight function, this is where all the code for generating details about that flight is going to be. So what does that mean for where I'm linking to in my flights.html template? Well, I want to link to the URL for flight, where flight is the name of that function. But I can't just give flight anymore, because this URL is a flight function that also has this flight ID parameter that's passed in via the URL. So if I just say, take me to the flight function, Flask is going to complain and say, wait a minute, I don't know which flight you actually care about going to. So in my URL for it, I need to tell Flask what flight I actually care about. And so that's what this is. URL for flight, comma, flight ID equals flight.id. So flight ID, that is the name of that variable that we were using just a moment ago in application.py. And flight.id, well, flight is this individual row that I got back from the flights table from that query. And to access the ID column of that row, once again, we're using the dot notation to say flight.id is the ID of the thing I want to go to. And so using this syntax, I can say, take me to that specific flight page. Now what happens on that specific flight page? Well, the first thing I do is make sure the flight exists, right? Select star from flights where ID is that ID, fetching that one row. If that row is none, if no row gets returned when I try and select that flight, well, there's no such flight with that number, so I better return an error message that says, sorry, no such flight by that number. But if that flight does exist, now I want to get the passengers. So I'm selecting names from that passengers list, where flight ID is equal to plugging in that flight ID there and getting all the rows. And I save that in a variable called passengers. And now on line 54, I say render template flight.html, passing in both the flight that I got back from when I queried for the flight up here, select star from flights, and also passing in all the passengers. So now my flight.html knows information about the flight, its destination, its duration, and also its passenger list. So inside of flight.html, what's happening here? It extends layout.html again. It's got a title of flight. And in the body, I have a heading that says flight details. I've got this unordered list just of information. Origin is flight.origin. Destination is flight.destination. Duration is flight.duration minutes. So that's nothing too crazy, just using that double curly braces to say plug in a value here. And flight was a variable that I passed in from Python. Then down here, I have another heading that says passengers. I have another unordered list. And for each passenger in my list of passengers, I'm going to create a list item that is just that passenger's name. I'm going to plug in to a bulleted list. And this else condition in Jinja 2 just says, the else condition specifically in this templating language means that if the passenger list was empty, if the for loop never ran, run this code. In this case, just saying there were no passengers. So what happens if I cd into airline 1 and Flask run this code? Address already in use because I'm already running a Flask application over here. I'll run Flask run again. We're running on this URL. So I go here. This is the book page. But recall, if I want to go to where I can see all the flights, I go to the /flights route. So if I now go to /flights, what I get is a heading that says all flights. And then in this bulleted list, 1 flight per line, where each one is going to be a link to that detail page. So right now, I'm at this URL /flights. But if I were to click on New York to London, for example, and go there, now notice my URL's changed. Now I'm at /flights/1, because clicking on that link took me to this route, /flights/ the integer flight ID, and I passed in which flight ID I actually wanted. So going to /flights/1 tells me here's the flight. Its origin is New York. Its destination is London. It lasts 415 minutes. And Alice and Bob are the passengers that are registered for that right now. If I instead just go to the URL and change flight/1 to flight/2, for instance, now I'm looking at this next flight. Origin Shanghai, destination Paris, 760 minutes. The passengers are Charlie and Dave. And if I try going to a flight that doesn't exist, flight 28, for example, when I don't have a flight number 28, now I get an error that just says no such flight. And so I've been able to create arbitrarily many of these URLs just by using this placeholder syntax, wherein I can substitute any arbitrary flight ID into this particular route. So questions about how that worked and how I was able to create detail pages for all of these individual flights just by using those routes and querying for the right data from the database. So all of this and more is stuff that you're going to get to try as you begin to approach Project 1, which will be released later today. And Project 1 is all about building a Flask application and using SQL commands in order to query databases, in order to read data and write to data and interact with data, building pages sort of like this that have detail views for certain items and so on and so forth. And so more information on that to come with Project 1. But for now, that's SQL. And next week, we'll dive into even more depth about how to interact with databases, and in particular, how to go about using and creating APIs, or application programming interfaces, that let us interact with data in an even more useful and programmatic way. So more on that to come. But for now, thank you all.